Good afternoon, everyone. It's me, Arjit. It's me,
It's me, Deepsan Mania.
and today we are going to present a short presentation on the topic skewness. So I'll begin with the introduction part. You will continue the next part, and you will solve the problem. So we'll conclude like that. Okay, so skewness, we all know about the various measures of this person in statistics, and we know like mean, median, mode are the central tendency. They give some idea about the characteristics of the distribution, but they alone are not, efficient, or they alone are not required, or they do not give the complete information about the distribution. So we need skewness for that. Skewness stands for lack of symmetry. So to give an example, I'll write any two distributions here. Okay, so we can have a look at this distribution, and if we take the mean of these two, we will get the same mean, that is 27.5. And if we take the standard deviation, it will be the same, which is 9.42. So we can see that the distribution of the value of mean and standard deviation of those two distributions are the same. So we cannot distinguish their characteristics. So here comes skewness. So if we plot the graph of these two distribution, one becomes something like this, and another becomes something like this. So we can see the variation of the distribution from skewness. And to calculate skewness, we have various formulas. Among which the first one is mean minus mode, and the next one, when the mode is ill or we cannot calculate the mode, there is bimodal case, then the formula will be 3 times mean minus median. And the next one is, so these are the three formulas that we can use to calculate the skewness. And next one is coefficient of skewness. So for coefficient of skewness, I'll just write the formula. And there are two methods from which we can calculate the coefficient. One is Carl Pearson's coefficient of skewness formula, and another one is Bowley's. And so for the Carl Pearson's, it's same like this, and divided by the standard deviation. So this will be the first formula, and the next one is and the third one, the Bowley's coefficient of principal will be Q3 plus Q1 minus 2MD, that is median, upon Q3 minus Q1. So this is all about some basic introduction of skewness. So I like to welcome Amit for his presentation further.
Thank you, Arjit. Now I am here to tell some extra information about the skewness and its types. Is Arjit has already explained about the measure of skewness. We all knew that measure of skewness helps us to determine the angle or the direction in which the frequency distribution departures. Now, talking about the skewness, first let's talk about the normal distribution. In normal distribution, let us assume that we took the data height of the students of class 11 and 12, and let's suppose we get this. This height is in meter. And this is the maximum point. Now, and this line is called line of symmetry. Here we can see that the line of symmetry divides both sides equally. This is negative side and this is positive side. Both negative side and positive sides are equal. So in this case, in this normal distribution, the coefficient of skewness is always 0. And now let's talk about the positive skewness and negative skewness. In case of positive and negative skewness, if we go through graphical method, then it will be very easy to understand. पोजिटिभ स्क्युनेस र नेगेटिभ स्क्युनेसमा चाहिँ के हुन्छ भन्दा कम्पेरिजन गर्दा राइट साइडमा चाहिँ राइट साइडको टेल चाहिँ पोजिटिभ स्क्युनेसमा चाहिँ लङ हुन्छ र नेगेटिभ स्क्युनेसमा चाहिँ लेफ्ट साइडको टेल लङ हुन्छ. दिस टु आर टेल. अनि यो नर्मल डिस्ट्रिब्युसनमा चाहिँ यो टेल चाहिँ इक्वल हुन्छ. नाउ लेट्स गो टु ग्राफिकल मेथड. You can see here this like mouse tail in this. So this in positive skewness in right hand side or positive side the tail is long, so this is called positive skewness. And let's talk about negative skewness. It is exactly opposite is positive skewness. We can see the tail in negative, long tail in the negative side. Now talking about the relation between mean, median, and mode. In this normal distribution, always the mean is equals to median and median is equals to mode. And in this positive skewness, always mean is greater than median and median is greater than mode. And in this mode is greater than median and median is greater than mean. That's all. Thank you.
Good afternoon everyone. I am here to solve the problem of skewness. question and I will solve you. First of all, we have to find mid value x, and then we have to find fx, and similarly fx squared. From the frequency we can find n, and n is 50. And after finding fx square and fx, we can find mean x bar. Mean x bar formula is summation fx by n. And the mean is 43.6. And similarly, we have to find standard deviation sigma. The formula is summation fx square by n minus summation fx by n square. And the standard deviation is 10.002. Finding standard deviation, after that we have to find median MD. And the median class is 30 to 40. After finding median class, we know the formula L plus n by 2 minus CF by F into I. L is 40, n by 2 is 25, and cumulative frequency is the cumulative frequency is the preceding term, that means it is 17. The frequency is 20 and I is 10. And the median class is 44. And as Arjit already have told, we know the formula skewness of, and the skewness formula is 3x bar minus mb over sigma. And the skewness is 10.1 minus 10.1. Thank you.